PHYS okay, PHYS206 for complex numbers. Okay, now we continue with the examples. So in this example, we have Z1, which is 2 plus 2i, and Z2 is 1 minus square root of 3i, and Z3 is equal to minus 2. So there are three complex numbers given. Okay, one of them is only real component, no imaginary component, and we would like to get some problems using this. Okay, now let's show them in polar form. Okay, what is the polar form of these three complex numbers? Polar forms. Okay, so we have now Z1. Let's consider this one. Z1 equals 2 plus 2i. First, we have to get the radius, or just okay, let's show this on complex plane. This is real x, and this is imaginary real x, imaginary y. Okay. So 2 is here, 2, and 2i is right there. This is 2. This is the point. Okay, this point is there. Now I would like to get this in polar form. Actually, you have to get the radius r and also this angle theta and so on, right? So r is the length of the vector that is drawn from the center to the point here. So how can we get this? It's very simple. It's just the square root of these squares of this summation of the squares of, okay, x squared plus y squared. Okay, if z is given by x plus iy, this is how we can get the magnitude. So now in our case, x and y are 2, so it's just 2 squared is 4, another 4 is 8 square root of 8. So r is square root of 8. R is square root of 8. Then we have to find this angle theta here, right there. Okay, so now angle theta, if you take the tangent theta, okay, so tangent theta is just y over x, but y and x are the same as 1, okay, so you get 1, 2 divided by 2, you get 1, okay, so now tangent theta is 1, and theta should be equal to arc tangent, okay, 1. So what angle gives you 1 if you take the tangent of it? It's just pi over 4, which is 45 degrees. Exactly, because it must be 45 degrees, because this is 2 units to the right and 2 units to the left, and this is the hypotenuse of this triangle, and obviously you will get 45 degrees. Okay, so we get that. Now, if you get theta, then any complex number can be written as r e to the I theta. So z now is equal to r, which is square root of 8, times e to the I pi over 4. Okay, that's it. So this is nothing but equal to just 2 plus 2i. Okay, so this is the polar form. Polar form. Okay, can I also write this as in sine and cosine? Of course, because the exponent gives you that. So that z can also be written as square root of 8 times cosine of pi over 4 plus I sine pi over 4. But what are pi over 4? Okay, cosine of 45 degrees and sine of 45 degrees. Okay, so you can get these values and then insert here, and then you end up with exactly the same thing. If you just put these angles here, okay, and then get the result and multiply by square root of 8, you get 2 plus 2i. Very simple. Okay, so the first example is solved. We have written this first example in polar form. Okay, now let's look at Z2. Okay, Z2 is this one right now. Okay, Z2 is this one. So Z2, so we finish this part. Z2 is now 1 minus square root of 3i. We would like to get this now, the radius, or just this length, radius or length. Actually, it's the radius, because in complex plane, usually we can draw this circle, and then this happens to be the circle, the radius of the circle. R is equal to, okay, R is equal to square root of 1 square plus square root of 3, you know. Just 3, 1, which is 4, which is 2. So R equals 2. So we get the radius, which is 2. Now the tangent, arc tangent y over x gives you, okay, arc tangent y is minus square root of 3, and this divided by 1 is just minus square root of 3. So what angle gives you? So what angle gives you minus square root of 3? It's minus pi over 3. In other words, minus 60 degrees. In this case, theta will be equal to just minus pi over 3. Then Z2 will be written as 2e to the I pi over 3. Pi over 3. If we write this in cosine and sine, it's just 2. Okay. Now cosine pi over 3 plus I sine pi over 3. So basically, if you get sine and cosine pi over 3, you get like this 1 over 2, but this is square root of 3 over 2. 2's cancel, and then exactly you get this one. Okay, 1 minus. Of course, this will be minus, because sine of pi over 3 is minus. Okay, good. So we solve this one, and let's look at Z3. Z3 has no exponent, so that R is just 2, you know, because it's the point right on the complex plane like that. Here, this real x, imaginary y, okay, this is just real minus 2 right there. So this complex number is right there on complex plane. So now the radius is just 2, because, you know, if you have this, radius is 2. So it's just R, actually. So Z3, which is equal to minus 2, okay? And R3 is equal to 2. Now, we have to get also angle. So what angle gives you 0? Because remember that we have now plus 0 times I. It means that the result is 0, okay? So to get angle, theta, we use again arc tangent 0, okay? Arc tangent 0, okay, but tangent pi gives you minus 1, so that theta equals pi. So that we have now 2 e to the I pi, okay? So this minus 2 is just equal to z equals minus 2 is equal to just 2 times e to the I pi, or 2 times cosine pi plus I sine pi. Of course, because sine pi is 0, but cosine pi is minus 1. Minus 1 times 2 gives you just minus 2. So this is the result. Okay. Now we finished also these examples. Now we are getting ready for questions.